Hi everyone, welcome back to Math and Mitchell, and we're going to be discussing parallel lines versus perpendicular lines. And basically we're going to go over what they are and how they're used in geometry. So first things first, perpendicular lines, are going to be looking something like this, where they cross and they create a 90-degree angle at each of these quadrants here. So it's a perfect cross or a perfect intersection. So you can see this usually in roads that you drive on, things like that. You'll see that they perfectly intersect on a 90-degree angle. Those are perpendicular lines. Next is going to be parallel lines, which these never intersect. So if you imagine like infinite lines, like we talked about in earlier lectures, these will never intersect, and they'll basically follow each other throughout the field that you're looking at, or the plane that you're looking at. And so these will never intersect, parallel lines will never intersect, and perpendicular lines will perfectly intersect at a 90-degree angle. So some of the basics of what classifies each. These are kind of the two extremes that you'll be dealing with, and they have some unique properties and relationships. So first, perpendicular lines you'll probably be using a lot in figuring out the perpendicular line to this equation. So say if we have this equation here, the question will be like, well, what's the perpendicular line to this equation? And so say this equation matches like this line right here, and you're trying to find the equation to this line. Well, there's a really simple relationship between the slope of this line. There's a relationship between that line and this line, and that is the slope of the first line. So let's say y1, or let's do m1. m1, that's the slope of, say, negative 1 over 2, is equal to the negative of the reciprocal of m1. So m2, let me rewrite this. M2 is going to be equal to negative 1 over m1. But m1 equal to your starting line. So let's just draw an arrow for our example here. So that's the equation they give you in the problem, and that slope is going to be negative 1 over 2. And so your slope of your perpendicular equation is going to be m2, which is negative 1 over m1. So if we solve for m2, we get negative 1 over negative 1 over 2, which equals 2. So as you can tell, I gave us two examples here to choose from, and we would know from that, just by looking at the slope, this is going to be the line that's perpendicular. Okay, so what's the relationship between parallel lines? Well, basically, they have the same slope, because, as you know, in order for them not to intersect at an infinite angle, there has to be the same rise and run for both. So it kind of logically makes sense. So from this one, we know that this is parallel. Now, the biggest thing that watch out for parallel lines is if they have the same Y-intercept. So these two do not have the same Y-intercept. so meaning they are parallel. But if they had the same y-intercept or the exact same equation, which would turn out to be the exact same equation, they would be overlapping and they would no longer be classified as parallel lines. So it's kind of cool that you can look at just the slope of each line and sort of determine if it's going to be perpendicular or parallel or neither, because some lines will just intersect, but they'll intersect at a weird angle, which we'll talk about later. And those are just classified as intersecting lines, not parallel or perpendicular. Parallel or perpendicular, remember, is a 90-degree angle versus not intersecting at all, which you can easily determine through the slope. So why do we want to use this? Biggest thing we can use with parallel and perpendicular lines is finding the relationship or knowing the relationship between lines. So, and we'll cover this more detail later, but the big thing to remember is that parallel lines give you a certain relationship, where if you have, and you'll be covering a lot of the relationships soon, but if we have two parallel lines, shown by here, then we have an intersecting line coming across, then we know that, for example, that angle and that angle are the exact same. Similar how we knew the slope is going to be the exact same. It would make sense that these two angles would be the exact same. And then these two are the exact same, these two are the exact same, and these two are the exact same. What's also cool is there's some properties where you know that this is a line, so that the angle from here all the way across to here is 180, right? So we know that this angle and this angle added together equals 180. There's some really cool properties where you can get into parallel lines and how, if you have an intersecting line that goes across both of them, how the angles on around one parallel intersection is equal to the other intersection. So that's a unique property of parallel lines. Perpendicular lines are really good for understanding or for guaranteeing relationships with like right triangles and different things like that. They're sort of the complete opposite of, as like I said, the parallel lines, and we'll get into some more properties later. But those are the two basics those are the two basic types of intersections that you'll be discussing a lot in geometry and some properties that go along with them.